Okay, so this is a BoostPack. This is just like the one I had in my gas-powered car. And, I replaced the lead-acid battery with it and ran it for, I don't know, a couple of years that way. But today, I just want to do a test and figure out how many watt hours, are in this. More like or amp hours. I'll get both of that off of this watt meter when I run this inverter, and drain this capacitor arrangement. And I'm going to be draining it through a boost converter that's going to step the voltage up. So as this goes down, it's going to go all the way down to, I don't know, 3 volts or so. And it's going to keep stepping that up to drive the inverter. So it should give us, a real world estimate of amp hours and watt hours out of a system like this. That's really necessary. As I explore this for solar and other options, I really need to know some real world numbers so that when we're making our own supercapacitors, if we get 2,600 farad, we need to know what that means in the real world in a practical case. So anyway, I'm charging these up. I'm going to get them all balanced out, charged up, and we'll do the test. Should be very interesting. Be right back. Okay, so we're all set up to run the watt-hour experiment. Get the amp hours, watt hours, get some sort of comparison between batteries and supercapacitors here. So we've got them charged up to 15 volts. You can see there. This multimeter is going to display the voltage on the supercaps. As it runs down over here, we're going to get all kinds of information as it runs over to the inverter as the load. I have not yet hooked it up, but let's go ahead and hook this up. Okay, we're going through the DC-DC converter. You can see the watt meter is now on. We'll go ahead and turn on the inverter. And we are now doing the run test. So, with that running, I can monitor the discharge rate over here. And, see how that runs. I can come over to here, get all kinds of information. You can see that we have a 12 watt load. This is a 12 watt load over here. This is going to cycle through. That's your amp hour at 14 volts. This is the watt hour. So we're going to let this run and see what we get out of this. Should be very, very interesting. All right, guys, we'll check back in on this later. Okay, so the light just went out. It ran for about an hour and 15 minutes. And even though the light's out, you can see it's still feeding in about 1.5 watts. But you can see it was almost 1 amp hour, 12.9 watt hours. So 12.9 watt hour, 1 amp hour essentially. And to give a comparison, this is a lithium iron phosphate battery. This is a 20 amp hour battery. So this right here would have to have 20 times this to equal this in capacity of amp hours. This has tremendous capacity, in amps, just instantaneous torque amps. But to get 20 amp hours, we need to get 20 of these. So basically this 6 capacitor bank here in series times 20 to get to this. So obviously the future is in miniaturizing this. If you look at Robert Murray Smith's videos or any videos, if you can ever get 2,600 farads in something small and thin, then you can easily match for size the amp hours. So if you could get this down into a small thin device rather than these big round cylinders times 20, all of a sudden you are looking at something that could fit in this case. And this is a pretty good battery. They're about 1,000 cycles I think on this one. They're still about 80% capacity. The headway cells like we're using in the Solon 125s, those are rated at 80% capacity at 2,000 cycles. And of course, these things are something like 1,000,000 cycles. So I really see supercapacitor technology as the future. And of course, I need to get back to experimenting, with the thin graphene supercapacitors to get these things to fit in a smaller form factor. So anyway, very interesting, something I've wondered about for a very long time. And these little watt meters are just great for doing this type of experimenting. I'm trying to get set up to do a bulk order on these. I'll probably put them up at teslamaker.com because I use these all the time for all kinds of interesting information. But anyway, that was the setup. That was the test. We now know in amp hours as well as watt hours, we're looking at about 13 watt hours and about 1 amp hour, at 13 volts. So the math all adds up. There you have it, folks. Let's all keep experimenting.